Today, we are going to build the ultimate modernized version of the Nintendo DS. I'll show you how you can make huge improvements to the system for free, add features that it was never meant to have, and reimagine one of the quirkiest handheld consoles of all time. So the first thing to get out of the way is that we're actually going to start with a new Nintendo 3DS, because well, there's really no reason not to. And when I say new, I don't actually mean that this is a new console. It's actually quite used. But Nintendo had some very confusing branding going on with their DS consoles. The 3DS is the successor to the DS. It's its own console with its own library of games, but it's also completely backwards compatible with just about every single DS game. It's got much more powerful hardware and a show-stopping feature that blew people away when it first came out. A 3D screen that you don't need a special pair of glasses in order to appreciate. Wow. Now, I can't really show it on camera, but if you get a chance, go check one out in person because it's pretty neat. A couple of years after the release of the 3DS, Nintendo rolled out the new 3DS, which featured a faster CPU, more RAM, and better head tracking, which greatly improved that 3D effect. But this wasn't really a new console. Outside of a handful of exclusive titles, it was basically just a better way to play 3DS games. Now, there's also the DS Lite, the DSi, the 2DS, the new 2DS, and then all of the different size variants, but sufficient to say, this is the best hardware, in my opinion, to play DS games on. So the very first mod we're gonna do this thing is probably gonna have the biggest impact from a functional standpoint, and it's also completely free. But here is where our story gets a little bit more convoluted. You're gonna wanna hack your 3DS and install a custom firmware on it. This completely unlocks your system and lets you do all sorts of fun stuff to it. Unfortunately, the 3DS that I got for this project came already hacked, so the process I followed to update it and get it running is gonna be significantly different than like 99% of you guys at home. That being said, there are plenty of great guides out there, and I'd love to link you directly to one, but the last time I did, YouTube removed the whole video, so I guess just Google it. Anyways, I've got the latest version of Luma 3DS running on my system, and my favorite feature is that it allows you to rip games to your SD card, and then you don't need the game carts anymore. We'll talk more about this later, but right now I want to talk about performance, because hacking your 3DS could also potentially lead to some big performance gains. So remember before when I said that the new 3DS has a faster CPU? Well, it does. It runs almost 4 times faster than the one found in a regular 3DS. Just only sometimes. See, the thing is, Nintendo only gives you that extra performance with specific games, and that list of games is quite short. So what Luma allows you to do is unlock those higher clock speeds all the time. By toggling this setting right here, we can unlock higher frame rates, faster load times, and an overall much improved gaming experience in pretty much every game. Now, like I said, we'll test all that later, but first, there's a problem. That improved performance comes at the cost of higher power consumption. You see, the battery inside the 3DS is quite small at only 1700 milliamp hours. And when you consider that it's powering the entire system plus 2 independent screens, it's already stretched quite thin. So what do you say we give it a little upgrade? Plan A was this massive tank of a battery that's actually made for a regular DS. It will fit inside of a 3DS with some light modifications, but once I got my hands on it, I realized that, yeah, it's a massive tank of a battery, and if I want to install it in my 3DS, it's gonna make it way thicker. So then I thought, okay, well, what about if we just did 2 regular batteries and then wired them together in parallel for twice the capacity? As you can see, that ends up being significantly thinner, so let's give Plan B a shot. And I do mean a shot because I saw a couple of forum posts of people saying they attempted this, but couldn't actually get it to work. So job number 1 was stripping down the batteries and figuring out what makes them tick. I removed some plastic around the contacts, which will make wiring them together easier, and then it was time to figure out what each pad does with my multimeter. As it turns out, the 2 outer pads are the positive and negative terminals, and then the middle pad is most likely for a battery ID signal. That'll be important later because the 3DS likely won't boot without that signal. With 2 leads soldered to our spare battery, I was just about ready to connect it back to the original battery, but that would have been a huge mistake. If you connect 2 batteries with different levels of charge, they'll rapidly equalize and potentially fail in a catastrophic way. So I made sure both batteries were charged to basically the same voltage, and only then was it safe to permanently join them together. Hopefully this boots. Hey, were the forums wrong? Okay, well that is very promising. It turns on, but I guess the question at this point is whether or not it's just drawing from one battery or it's actually drawing from both batteries. So how are we gonna test that? Well, another benefit of hacking your 3DS is that you can run homebrew software. And turns out somebody made an app specifically for benchmarking batteries. I'll share the results later after I give both these batteries a full charge, but sufficient to say both of our batteries were definitely working. So now I think the next thing that we need to do is, well, actually, the next thing we need to do is charge this thing so that I can keep using it. But I just spent 15 minutes looking for this stupid proprietary charging cable. So I think actually what I'm gonna do is replace this charging port with something that's a little bit more modern and convenient to use. One thing I kept reading before starting this project is that 3DSs are really hard to disassemble. And after tearing into it to install this charging port, I gotta say, they really are. It's a multi-layered disassembly with dozens of delicate ribbon cables, hidden connectors, and latching mechanisms. Of particular note are these 3 connectors in the upper right-hand corner, 2 of which are on the underside of the motherboard. These guys forced me to do something that I really didn't want to do, but I'm getting ahead of myself, because at this point I had the motherboard free and the charging port was finally ready to be modified. Now, if you've seen any of my other videos, you probably know that my plan is to replace it with a more modern USB-C port. That way I can ditch the proprietary cable and charge the 3DS with the same charger I use for all my other devices. But first, I need to remove the original port. So I started by heating up my hot air gun and covering all the nearby components with this high temperature insulating Kapton tape. This allowed me to melt the solder holding the port in place without damaging any of the nearby components. I then cleaned up all the remaining solder with a solder wick, and now we have a blank canvas ready for our upgrade. A little more Kapton tape kept our new USB-C port secured in place while I soldered it to the motherboard, and here's the funny thing about this port. Most of these connections that I'm doing right now don't actually do anything. One of them is a 5-volt terminal for charging, and the rest are just ground lines that are mostly there to firmly anchor the port in place. That way, this little micro PCB doesn't get ripped out the first time you plug a USB cable into it. Now, this last step here isn't really necessary, but if you want your 3DS to still be compatible with some of the charging dock accessories, you'll need to cut and reinstall these little brackets. Honestly, this was kind of a pain in the butt, so I'd skip this step unless you already have a dock that you really want to keep using. All right, so there we go. We added a USB-C charging port to our Nintendo DS. And well, we still have to test it. There's a couple of things that I want to do before reassembling everything because I still have easy access to the motherboard. The first of which is wireless charging. I showed in my PSP video that this isn't always that hard to do, and it makes it so much more convenient to charge the system. So the way I'm hoping to do that is with this weird little phone accessory. This glorified sticker lets you add wireless charging to any phone by blocking your charging port. Yeah. Like I said, it's weird, but it is cheap, and I know from previous experience, it should have everything that we need hidden inside of it. Peeling back its exterior wrapper exposes this wireless charging coil and a PCB that controls its output. So all we need to do is transplant those 2 things into our 3DS. I desoldered the original USB-C connector and instead connected 2 wires. Thankfully, these pads are clearly labeled, so one is for the positive 5-volt output terminal and the other is a ground. And I think you can probably guess how we're going to connect those back over on our 3DS. Yeah, that's right, we're going to connect them directly to the same lines that we just used for our brand new charging port. It really is that simple. Well, kind of. One thing I hadn't accounted for just yet is the added bulk of all our new parts. So after a partial reassembly, I still had to modify the back panel. This included filing out a larger opening for the USB-C port, removing some material to create a bit of vertical height, and drilling out a big ol' hole for the wireless charging wires. We'll end up removing even more later, but this was good enough for testing. Okay, moment of truth. Charging indicator. Good sign. Come on, don't brick. And here is where the real pain of this project started. After installing these mods, our 3DS just wouldn't boot. So I disassembled everything and made sure all of the ribbon cables were properly connected. And sure enough, I found a couple that I didn't think were properly seated. Like I said, these connectors can be kind of tricky. So I buttoned it all back up and then tried again. Please, 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 please. Nothing. What is wrong with you? Not being one for giving up, I disassembled the console one more time, and this time I paid special attention to those cables in the top right corner of the motherboard. These are notorious for preventing the system from booting if they aren't seated correctly. Blue light, blue light. Do something. Ah, turned off again. What is wrong with you? At this point, I was at my wit's end, so I tore further into the system, and I think the root of my issues was in fact those cables that connect the screen, camera, and speakers. But I wasn't able to find any replacements on such short notice, so I did something that I didn't want to do. I called in my backup. The mods I do in these videos are generally pretty high risk, so I often have a backup console on hand in case I screw up the first one. If all goes according to plan, I don't need it and I can keep it as a collector's item. But if worse comes to worse, like it did here, then I can use it as a backup and keep these videos coming out on a semi-regular basis. And don't worry, I will order parts and fix that first 3DS on my own time. Now, of course, using a second console meant redoing all the hacking and soldering from before, but we'll just use a little bit of movie magic and skip right over that to the point where I was ready to test all of the mods on my second 3DS. A moment of truth round. Honestly, I forget how many rounds it's even been. Okay, I got the wireless charger hooked back up. Let's see, do we get boot? And we do. Okay, took us a while to get here, but now we can actually test and see if this wireless charger works. So let's head over to my bedroom. Oh, yes, look at that. Yay, we're charging. Take it away, stops charging. Put it back, it starts charging. Heck yeah. All right, so now that we've got our charging and our battery mods out of the way, the next thing that I want to add to our 3DS is Bluetooth support. Because at this point, I don't even think I own a single pair of wired headphones anymore. And I know that might sound a little crazy to you guys, but I actually did this once before in a previous project, my modern iPod video, and I'm hoping I can use all of the things that I learned there in order to pull off something similar here. To start, I grabbed this generic Bluetooth transmitter and receiver. Much like the wireless charger, we're gonna harvest what's inside of it in order to pull off this operation. And what an operation it was. It ended up being a lot harder than I initially thought to add Bluetooth to the 3DS. So let's break down the process one step at a time. First, I had to prep the board. This included removing the factory battery, mapping out which pins were responsible for the left and right audio channels, removing any unnecessary components, and finally adding some new leads that will connect back to the 3DS. Which is our next step. Here, I'm grabbing the audio signal from the 3DS's headphone jack and then rerouting it back to the Bluetooth board. Now, I am missing a key piece of the puzzle here, and we'll come back to that in a moment. But first, because I removed that factory battery, I had to connect the Bluetooth board to the 3DS's battery. Thankfully, they work at the same voltage, so this was as easy as soldering in 2 additional wires. And with that, I was finally ready to test the setup and find out that I was missing a big piece of the puzzle. There we go. That's in pairing mode. Does that work? I think they're paired. Let me try. I think maybe here. There we go. Yes, now it's working. In order to activate the headphone port, there needs to be something physically in there. So maybe I'm gonna need like a switch or something like that in order to do it. Unlike many other devices, it seems like the 3DS only routes an audio signal to its headphone jack when something is actually plugged in, which presents an interesting challenge for us. So the first thing I had to do was figure out how it knows when something is plugged into that port. There must be some sort of switch in there. So I started probing around and I noticed that there was no continuity between 2 of the ground pads, which is definitely a bit weird. Usually all of the grounds are continuous. So I plugged in the cable, and sure enough, then I had continuity. So maybe that's our switch. To test it, I wired in my own physical switch, and if I'm right, closing the switch should activate the headphone jack, mute the 3DS's speakers, and send the audio signal we need to the Bluetooth board. And after trimming the 3DS's shell a bit more, I was ready to test my theory. Currently, you can hear music is playing, so if I flip the switch, music stops. Yes, okay, so it thinks a pair of headphones are plugged in now. Now, we aren't done with that switch just yet, but working with it reminded me of another thorn in my side, the switch on the Bluetooth board. It toggles between off, transmitting mode, and receiving mode. And when it first enters either transmitting mode or receiving mode, it'll initiate a pairing process that just keeps looping until something gets connected, which isn't ideal because it means that if you aren't using Bluetooth, it's always trying to pair in the background and just draining the battery. So I found this multi-poled switch, and I think it solves both of our problems at the same time. Connecting one circuit to the transmitting pads means that the board will wake up and enter pairing mode, and then connecting a separate circuit that activates in the same position will fool the 3DS into thinking something's being plugged into the headphone jack, thereby solving both of our problems at the same time. But let's see if it actually works.
Volume. Now when I flip this, volume off, Bluetooth pairing. Awesome.
So now that we know that it works, our next job is making all of this look less like a fire hazard and more like an actual game console. And in order to do that, we are going to need something that I am very excited to be unboxing. Today's video is sponsored by Bamboo Lab and their brand new H2D.
Now, I'm tempted to call this thing a 3D printer, but the truth of the matter is it is so much more than that. They took everything that I love about the X1 Carbon, improved it, and then added a bunch of features that nobody saw coming. So to start, it's bigger. More capacity means bigger prints, means more possibilities. It's also got 2 print heads, which means you can seamlessly switch between different materials for faster printing and combining different types of materials. Think hard and soft materials in the same print. There's new and improved cameras, better air management, and a whole suite of other improvements. They also completely overhauled the AMS, and there's now a built-in filament dryer. And then there's the AMS HT, which is specifically designed for working with tricky and high temperature materials. But all of that isn't even the coolest part. You see this green tint? Yeah, that's because this thing has a freaking laser in it. I've got the full fat 40-watt module, which allows you to blast right through plywood and a whole host of other materials. So yeah, there is so much to cover here, but I honestly think we should just start using this thing, and then I can show you all the other cool features as we actually use them.
As you probably already guessed, in order to cram all of our new parts into the 3DS, we're gonna need to design a new back for it. And here, I actually like to start by modeling the parts that we're gonna keep from the original design, as well as all of our new parts. It's a bit more upfront work to do things this way, but it'll make all of our subsequent design work a lot easier. I printed a really simple replacement for the snap-on rear back plate, and this allowed me to check all of my measurements, make sure my ports were in the right position, and all of that fun stuff. It was also my first real print on the H2D, and I noticed this cool light bar underneath the build plate that basically functions like a big progress bar. Definitely a fun touch. Testing this part revealed that most of my measurements were correct, and I could move on to the more challenging part of this build. And here I had to make a big conceit. If I wanted to add just 1 or maybe 2 of those new features to the 3DS, I probably could have done it without changing its form factor. Adding all 3 though, that would require me to add approximately 6mm to the overall thickness of the system. But hear me out. I think we can use that extra girth to fix one of the biggest problems with the 3DS. As a person with larger hands, I actually find the 3DS to be pretty uncomfortable to hold for long periods of time. So what if we made it a little bit more ergonomic? My first pass at this new backplate included cutouts for each of the new components, as well as channels for routing the wires. And then on the opposite side, I utilized the added thickness to create 2 contoured finger holds. Now, instead of just supporting the system, I should actually be able to get a grip on it. Or at least that's what my theory was. I wouldn't know how it felt until I actually printed it out. And here we have a perfect example of why the H2D is such a huge leap forward for 3D printing. At this point, my model had grown in complexity to the point where printing it required the use of support and support interfaces for all the floating sections. I always hate this part of prototyping because using support interface dramatically increases print times. Depending on how complicated your model is, this can require dozens or even hundreds of filament changes, which really adds to the print time. But because of the H2D's dual nozzles, it can quickly toggle between 2 different filaments. Printing this model on my X1 Carbon would have taken 4 hours, but on the H2D, it was able to do it in half of that. And now we can test out my new backplate. All the components fit nicely into place, and after securing them down with a little bit of temporary tape, I was able to install the backplate on the system and see how it felt. Actually,
Look, I know this is gonna be a controversial choice that I made here, but this feels pretty dang good to me. And if you think about it, the points where I'm holding it aren't actually any thicker. My fingers are still in the same spot, but now I have all this extra purchase here to really hold on to the console. And then I even actually have a nice little ledge here to rest my fingers on for the shoulder buttons when I'm not using them. So now that I know all of it works, I want to do one last revision of the backplate and add a special little touch. I spent a few hours further refining my design by rounding over any hard edges, tightening tolerances, and adding these two recessed areas on the back side. Bamboo sent over something that I think might make the system even more comfortable to hold and use here. After printing my revised design, I removed the build plate, installed this heavy-duty steel tray, and then clipped the 40-watt laser cutting head into position. And yeah, it really is that easy to install it. The changeover process took a grand total of like 30 seconds. So to add a bit more grip and style to the backside of my 3DS, I want to try cutting some leather with my new laser. But I also didn't have a way of securing it in place, so before I loaded it into the H2D, I lined it with a layer of very thin and very sticky double-sided tape. After importing my shapes and punching in a few parameters, I hit start on my very first laser cut. And honestly, if you blinked, you might have missed it, because this thing is super quick, especially when it's cutting through thin materials. But turns out I still have a few things to learn about running a laser, because getting it to cut through both the double-sided tape and the leather took a few attempts. I actually learned later that there's a much better way to do this, and I'll show you that method soon, but for now I had my leather pieces cut, and after peeling off the adhesive backing, I stuck them onto the new shell. Check this thing out. That is so cool. I can't believe I get to incorporate leather work into my projects now, and it was remarkably easy to cut it. I mean, sure, I had to attempt it a few times to dial in the settings just right, but now that I know, that was fantastically easy and super quick too. So now I've got a few more things planned for this project, like stealing a feature from the 3DS's younger sibling, the Nintendo Switch. And all I'm gonna need in order to do that is this simple USB right angle adapter. I'm a big fan of charging docks, so I want to build one for my 3DS. It's honestly just nice to have somewhere to put things, but it'll also mean that my 3DS is always fully charged and ready to go. So step number one was modeling the right angle adapter. And once I had that figured out, I basically just built a simple shell around it. There isn't a lot to this design as it doesn't have any internal circuitry. However, it is going to allow me to test something on the H2D that I am very excited about. It can print both hard and soft plastics at the same time. So for this dock, the shell is printed in a hard PETG, and then the inside is lined with a soft TPU. This will protect the console and keep it from getting all scratched up when it's placed in the dock. I even printed the lower cover with TPU feet so that it doesn't slide around on smooth surfaces. And because the plastics are printed at the same time, they're fused together without the need for any adhesives. It's pretty awesome. So the USB adapter goes in here, the bottom cover locks it in place, you connect your USB cable, and now you have yourself a charging dock. Oh, and another feature that I stole from the Nintendo Switch is this little index key right here, which guides the system into place. Without it, it'd be really annoying to align the 3DS with that concealed USB connector. Now, if you'll turn your attention down here, you'll see that I left this little recessed area blank, and that's because the 40-watt laser can also cut wood, which is gonna change things for me in a big way. Bamboo must have heard that I'm a big walnut enthusiast because they sent over some samples of their walnut plywood, but just a plain piece of wood would probably look pretty boring. So I opened up Photoshop and created my own custom logo for this project, one that Nintendo's lawyers will hopefully recognize as legitimate parody. In the past, I've done parts like this on my CNC, but there I'm limited in resolution by the size of my cutting head. The cool thing about the laser is that I'm working at a resolution that's measured in microns, so I'm able to give way more detail. And you might think that the laser is just burning the surface of the wood, but with the right settings, you can actually vaporize entire layers of wood to create a really cool 3D effect. With a couple of drops of CA glue, I was able to install it on the front of the dock, and then I was ready to move on to actually finishing this project. First, I reprinted the rear shell at a much higher level of detail and in the same black PETG that I used for the dock. That way, everything will match nicely. Printing at these finer layer heights takes a while though, so while the H2D was busy with that, I busied myself by disassembling the 3DS and then breaking out my die grinder. In order to make connecting all of our wires as easy as possible, I decided to hack away at the mid-shell. I left most of it intact for structural support, but removing these two key areas will make accessing all of our solder points on the motherboard a lot easier. And with that, our new rear shell was finished printing, and I also decided to recut the leather grips in some contrasting brown leather, which I think will really class up the console. And here, I did things the way I probably should have done them from the start. In addition to the laser, you can also attach a simple cutting head to the H2D. If you look super close, you'll see that there's a very small and very sharp knife on the bottom of this module. So you adhere the leather to this tacky plate. Again, I pre-applied my double-sided tape, and then you have it cut out whatever shapes you want using the same software as the laser head. You can also use this head to cut things like vinyl stickers, cardstock, and so much more. Oh man, look at how good that looks. Now that we've got the backplate all finished, we should, I think, wire this thing up and see if it works as a single integrated console. I won't bore you guys with the details of the final wiring, as we've done all this before in previous steps, but when it came to installing the various PCBs and routing the wires, this time I made things a little more permanent. With the careful use of some CA glue, I was able to keep all of our new internal components from rattling around, which is important for the longevity of a mobile console. So with these last two screws in place, I was finally ready to start using and testing my new 3DS XL. Like I said before, I know making this console thicker is going to be a controversial choice, but think about it. Isn't this what everybody's been telling cell phone companies to do for years? Just make your device thicker and give me ridiculous battery life. Well, yeah, on that front, this battery works great. Even with the overclock, we're getting well over 8 hours of battery life in game, which is right in line with what you'd expect from a battery that's twice as large. Charging is also way more convenient too, thanks to the wireless charger, even if I don't have nearly as many excuses to use it anymore. And I'm happy to report that the little Bluetooth board in here must sip power, because whether or not Bluetooth is on or off, I'm not seeing any noticeable decrease in battery life. But I am very much enjoying the ability to hear all these wonderful retro sound effects and music through a pair of wireless headphones. And circling back to the overclock, here I was expecting to see a big difference in terms of load times and game performance, but honestly, not so much. Certain games like Metal Gear Solid see a big improvement in terms of frames per second. However, loading times and the vast majority of titles are only ever going to see small improvements at best. That being said, once you hack your 3DS, overclocking it is as easy as pressing a few buttons, so it is still a free upgrade. And speaking of hacking your 3DS, now I don't have to worry about game cards at all. All of my games are stored and booted directly from the SD card, including a whole bunch of classic and retro titles. And on that subject, I actually think I found a way that I could have made my modded 3DS significantly thinner without compromising on any of the mods. But the purists out there are gonna hate it. I actually made a whole separate bonus video talking about all of the things I would have done differently if I had to do this project again. And that video is currently live for channel members. So check that out if you're interested. And on that note, that is it for my modern DS. Thank you so much for watching, and I will see you guys in the next one. Peace.